Now comes the math. Once you believe you have enough to solve the problem, do so. There isn't a prescription for how to do this or a flowchart or a list. It depends on the math involved and your skills. Every scientist engineer has a mathematical toolbox. In this toolbox contains all the math that they know and they can use to solve problems. One goal as you go through all your math, science, engineering courses is to increase the number of tools in your toolbox. Remember, even though you took a course in calculus, doesn't mean those tools are in your toolbox if you do not know how to use them to solve problems. It only becomes a usable tool for you when you are comfortable enough with the topic to know when to use it and how to use it to solve problems. Also, tools rust if not used. You can lose the ability to use tools if you do not practice them with regularity. One piece of advice: do not plug in numbers until the end. Manipulate variables for as long as possible in your equations. Doing this allows you to see connections between variables you would otherwise miss. Also, because equations can simplify, this makes solving problems easier in the long run. Sometimes I will put in numbers if I think it dramatically simplifies an expression that could get very nasty later on. For example, before I kept the position of the professor as x sub p, I didn't put in numbers, but I did put in 0 for the initial position of the raptor. So let's solve. I have two equations for x. X is equal to the velocity of the raptor times time, and x is equal to the position of the professor plus the velocity of the professor times time. So I just set the right hand of each equation equal to each other. Now I'm going to bring the velocity of the professor times time on the other side of the equation, which is a minus, and then I factor out the t from both of those terms, so I get a difference in the velocity times time is equal to the initial position of the professor. Now I can solve for time, which is one of the things I'm looking for, which is the position of the professor initially minus the difference in the velocities. I can now substitute that into this first equation to get the position at which the raptor catches the professor, which is just the velocity of the raptor times time. Now I know all of these terms, so I can go ahead and plug in numbers. The time is 22.2 and it's seconds because everything was in SI. And the position, which is that time times the velocity of the raptor, is 556 meters.